Hi, today we're going over section 5.9, complex numbers, powers of I, and conjugates. In this video, we'll talk about a little definition of complex numbers, and then we will add and subtract and multiply the complex numbers. We will be going over problem 5 and problem 6. First of all, we just learned about imaginary numbers. That's one part of a complex number. A complex number has a real part and an imaginary part. In the previous video, we multiplied and divided imaginary numbers. Now we have to learn how to do addition, subtraction, multiplication, and division for complex numbers. How do we figure that out? So look at the definition. If a and b are real numbers, then any number of the form a plus bi is called a complex number. A plus bi. So now you have an imaginary and a real. Oh, that's so complicated. Complex number. Note, any real number can be written as a complex number. You would just add 0i. Okay, I know what a complex number is now. Can we do the 4 basic operations in the set of complex numbers? Add, subtract. Okay, when you think about adding and subtracting, I want you to have this firework word in your mind. What does it mean to add and subtract? It means to combine like terms. So get that in your notes. I'm trying to combine like terms. So I look for the real numbers and then I look for the imaginary numbers. That's it. And combine those like terms. So -1 plus 9. And then I have -8i minus 3i. You just group the real numbers and the imaginary numbers. So in the end, A would be simplified by combining like terms. I would have 9 minus 1, which is 8, so 8, and then -8 minus 3, which would be -11i. That's your complex number. You do the same thing for B and C. You can rewrite it if you want to. So -3 plus 1, putting the real numbers first, and then 2i minus 3i, putting the imaginary numbers, and then combining the like terms. So -3 plus 1 is -2, and 2 minus 3 is -1, so minus I. -2 minus I. Let's do this one more time. Notice C is a subtracting. This is a common student error. They forget to distribute the negative. Don't let that be you. -9 and minus 2i. Just be careful with that. So when I look at the reals, it's 5 and -9. When I look at the imaginaries, it's -3 and -2i. So 5 minus 9, and then -3i minus 2i. Especially that 2 sometimes gets forgotten, so make sure to distribute the negative. All right, 5 minus 9 is -4, and then you're combining a whole pile of negatives here, so minus 5i. That's how you add and subtract complex numbers. Let's multiply. How do I multiply complex numbers? What's your big firework word? I want you to put in your notes, distribute. I'm going to distribute. So I'll take the 6i out front and distribute it into the parentheses. Okay. So on letter A, I would get 12i minus 18i squared. Remember, I squared is -1. I never write I squared. When I get completely simplified, I substitute that -1 in there. So I plug -1 in here, which would cause this to be a positive 18. Negative times a negative, positive. Now that's my real portion. So I have 18 and then plus 12i. There's your ending complex number in the correct form, a plus bi. Okay, who thinks b should be 4 squared and minus 2i squared? No, not you, because you know that in order to square binomials, you have to distribute. 4 minus 2i times 4 minus 2i. You cannot distribute the 2 as an exponent if you're adding or subtracting in the middle. Now, if you're multiplying it, so if I had x2i squared, I can distribute that squared because I'm multiplying, but not if you're adding or subtracting. Anytime you're combining, adding and subtracting with multiplying, can't do it. Okay, clean that up. So I know I need to distribute, so I take the 4 through. So 4 times 4 is 16 minus 8i. Then I take the negative 2i through, minus another 8i, and then plus 4i squared. Notice again, when you're multiplying, you're going to see this I squared, so you just plug in -1. Now this piece isn't an imaginary term, it's a real term. So just being aware of how to combine those like terms after you distribute. Okay, so 16 minus 4 would be 12, and then -8 and -8 is minus 16i. There's your complex number. We've got one more to do. Once again, distributing. So this would be root 5 times root 5. So root 5 squared. So that undoes each other, and you're just left with 5. And then plus 5 root 5i. And then you distribute the negative 5i. So negative 5 root 5i. And then minus 5 times 5 is 25. And I times I is I squared. Did we have to go through and distribute all of that? No. How many of you saw the pattern, the difference of squares? A minus B, A plus B. This is the difference of squares, and this is why that works. Notice the middle terms add to 0. 5 root 5i minus 5 root 5i adds to 0. Now I just have 5 minus 25i squared. Remember, the difference of squares is a squared minus b squared. And then we discussed previously that I squared is -1. So anytime you have this difference of squares with a complex number, you're going to get this new pattern called a squared plus b squared. Now you don't have to worry about the I. If I see a plus b, a minus b, I just consider the a and the b without the I. So I just take root 5 squared, which would be 5, and then I take 5 squared, which would be 25. So 5 plus 25, this would be 30. Notice minus a 25 times a -1, that becomes plus. Okay, so C is 30. I hope that helped learn how to add, subtract, and multiply. Next time, we'll learn how to divide. See you then.